Look up at the night sky. What do you see? Countless tiny lights, twinkling and shimmering. Those are stars. They are like distant beacons, each with its own story and history. Each star is a giant, burning ball of gas, incredibly far away, like cosmic campfires lighting up the vast darkness of space. They are composed mainly of hydrogen and helium, undergoing nuclear fusion in their cores. Stars have fascinated humans for thousands of years. They have been a source of wonder, inspiration, and mystery. Ancient people saw pictures in them, told stories, and used them for navigation. Constellations were born from these stories, guiding travelers across seas and deserts. Stars are fundamental, the building blocks of galaxies. They are the architects of the universe, shaping the cosmos with their immense gravitational pull. Our galaxy, the Milky Way, has hundreds of billions of them. Each one contributes to the grand tapestry of the night sky. Our own sun is a star. It is the closest star to Earth and the most important for our survival. It gives us light, heat, and makes life on Earth possible. Without its energy, our planet would be a lifeless, frozen wasteland. Without the sun, our planet would be a frozen dark rock. The sun's energy drives weather, climate, and supports all living organisms. Stars are the powerhouses of the universe, constantly working, fusing atoms, creating energy. This process, known as nuclear fusion, powers the stars and produces the elements necessary for life. This energy travels across space as light and heat, reaching us after a journey that can take years or even centuries. The light we see from distant stars is a glimpse into the past. Imagine the universe without stars, cold, dark, and empty. Stars bring warmth, light, and life to the cosmos. Stars are like the universe's engines, driving everything, creating conditions for planets to form, and even creating the elements that make up planets and us. They are the forges where elements are born. The iron in your blood, the calcium in your bones, all cooked up inside stars. We are, quite literally, made of stardust. So, when you look at a star, you're looking at your cosmic origins. It's a humbling and awe-inspiring thought. What if you could get really close to one? What mysteries would you uncover? What if you could jump into a star? The idea might sound crazy, but it's through such imaginative thinking that we push the boundaries of our knowledge. It sounds crazy, but thinking about crazy ideas is how we learn. It's how we make discoveries and expand our understanding of the universe. Let's embark on a thought experiment. A journey to the heart of a fiery giant. Imagine the heat, the light, the immense power. We'll explore the science, uncover the physics, and see what the universe has in store for such a daring adventurer. The journey will be filled with wonders and revelations. Buckle up, it's going to be quite a ride. The universe is waiting to reveal its secrets. What exactly is a star made of? Have you ever wondered what goes into the making of these celestial giants? Stars are mostly hydrogen and helium, the building blocks of the universe. These are the lightest and most common elements in the universe, forming the core of every star. Think of a star as a giant cosmic balloon filled with superheated gas, constantly in motion. About 75% of a star's mass is hydrogen, the simplest and most abundant element. And about 24% is helium. Stars are unbelievably hot, reaching temperatures beyond imagination. Our sun's surface is about 5,500 degrees Celsius, a temperature that can melt almost anything. But that's just the surface. The real heat lies deeper within. The core of our sun is around 15 million degrees Celsius, a furnace of unimaginable heat. This incredible heat and immense pressure allow stars to perform nuclear fusion, a process that powers the universe, where hydrogen atoms are smashed together to make helium, creating new elements in the process, releasing a tremendous amount of energy that lights up the cosmos. Stars come in different sizes, each with its own unique characteristics. Some are much smaller than our sun, like red dwarfs, which are cool and dim yet fascinating. Then there are giants like blue giants, red giants, and even supergiants, each more massive than the last, hundreds or thousands of times bigger than our sun, dominating the night sky. The average density of a star like our sun is about 1.4 times the density of water, a surprising fact. The core of the sun is about 150 times denser than water, a critical factor for nuclear fusion to occur. This density is crucial for nuclear fusion to occur, enabling stars to shine brightly. Gravity tries to crush the star, while fusion pushes outwards, creating a delicate balance, keeping a star stable for billions of years, a testament to the wonders of the universe. You've decided to take the plunge. You're in your imaginary, super-advanced spaceship, heading towards a star like our Sun. The first thing you'd notice as you get closer is radiation. Stars pump out enormous amounts of radiation across the electromagnetic spectrum. Your spaceship would need serious shielding to protect against this radiation. Next, you'd encounter overwhelming heat. The closer you get, the hotter it becomes. The star is like a giant furnace, radiating heat in all directions. Your ship's cooling systems would be working overtime, pushing them to their absolute limits. And then there's gravity. Stars are massive, with a powerful gravitational pull. As you get closer, your ship will accelerate faster and faster. For our thought experiment, you're jumping in, letting gravity do its work. The star's pull becomes stronger and stronger. It's a one-way trip now, no turning back. The star's immense presence would fill your view screen, a colossal ball of fire growing larger with every passing moment. You're hurtling towards the star now. The heat is unimaginable, but you press on. Up close, the star is a world of fire, a raging inferno that fills your entire field of vision. You'd see features like convection cells and solar flares, giant eruptions of plasma. If the star is like our Sun, it has an atmosphere, with the outermost layer called the corona. You'd pass through this first, like flying through an invisible wall of fire. As you get even closer, you approach the photosphere, the layer where the gas becomes opaque. The temperature here is thousands of degrees. Your spaceship would start to glow, then melt, then vaporize. And what about you, the brave jumper? You wouldn't last long. Tidal forces would stretch you, but you'd be vaporized by the heat long before that. Your ship has disintegrated, and you? You're part of that cloud of superheated gas. You wouldn't feel pain for long. Your entire body would be instantly obliterated, vaporized. There's no splash when you hit a star. You're becoming part of the star itself. A star is a plasma, a seething soup of charged particles. Your atoms, now ionized, are indistinguishable from the star's atoms. They join the chaotic dance, swept up in the star's currents. The pressures are beyond comprehension, millions of times Earth's atmospheric pressure. Everything is reduced to its most fundamental components: protons, neutrons, electrons. Your matter remains, now part of the star, contributing to its vast bulk. This entire process would be incredibly fast, a blink of an eye. Jumping into a star isn't just a journey to another place, it's a journey into another state of existence. You've become one with the star. Your atoms are now mingling with its plasma. Stars have structure layers like an onion. Each layer plays a crucial role in the star's life and energy production. The core is where nuclear fusion occurs, releasing enormous amounts of energy. Surrounding the core is the radiative zone, where energy is transported outwards by photons. It can take a photon hundreds of thousands of years to travel from the core to the next layer. Beyond the radiative zone is the convective zone, where hot plasma rises, carrying energy with it. Finally, we reach the photosphere, the visible surface of the star, from which light can escape into space. It's a complex, dynamic system, all working in concert. The star you've jumped into won't last forever. Stars have life cycles. They are born, live, and die. Their story begins in vast, cold clouds of gas and dust called nebulae. Gravity pulls clumps of this material together, eventually igniting nuclear fusion. Once fusion begins, the star enters its main sequence phase, the long, stable adulthood of a star. Our Sun is currently in this phase, fusing hydrogen into helium. The length of the main sequence phase depends on the star's mass. Massive stars burn through their fuel much faster, while smaller stars can live for trillions of years. When a star runs out of hydrogen fuel, it enters old age, becoming a red giant. After the red giant phase, the Sun will shed its outer layers, forming a planetary nebula. The core will remain as a white dwarf, slowly cooling down over billions of years. Massive stars have a more dramatic end, exploding in a supernova, scattering elements into space. You jumped into a star, were vaporized, and your atoms became part of that star. What happens to those atoms in the long run? It depends on the star's ultimate fate. In a sun-like star, your atoms are now mixed into its plasma, part of the stellar mix. When the star reaches its red giant phase, your atoms could be expelled back into interstellar space. This material will mix with other gas and dust, potentially forming new stars and planets. Your atoms could become part of a new world, or even a new life form. In a massive star destined to go supernova, your atoms would be blasted out into space. They would travel across the galaxy, enriching the interstellar medium. Your atoms would be recycled, contributing to the ongoing story of the cosmos. You are stardust, and to stardust you shall return. Stars are more than just distant lights. They are the crucibles of creation, the engines of cosmic evolution. They are the beacons that have guided humanity for millennia, inspiring myths, guiding sailors, and marking the passage of time. Your atoms, our atoms, were forged in the hearts of stars that lived and died long before our sun was born. These ancient stars went supernova, scattering their enriched guts across the cosmos. We are made of stardust. Every element in our bodies, every atom, was once part of a star. The sheer number of stars is astronomical, almost beyond comprehension. There are more stars in the universe than grains of sand on all the beaches on Earth, each one a potential sun for other worlds, a source of energy and light. These stars could host planets with conditions ripe for life. Stars gather in vast collections called galaxies, shaping the structure of the universe. These galaxies are the building blocks of the cosmos. They are essential for life as we know it, providing energy and creating elements. Without stars, there would be no planets, no life, no us. So that hypothetical jump into a star, it's a journey into the very essence of the universe. It's a dive into the heart of creation itself, a reminder of our origins and our destiny. We are intrinsically linked to these celestial giants. The next time you look up at the night sky, ponder those distant suns. Think about the light that has traveled for millions of years to reach your eyes. Remember their immense power and your own intimate connection to them. You are a part of this grand cosmic story. You are a child of the stars. Every breath you take, every step you make, is a testament to the stars' legacy. The universe, through you, is looking back at itself. We are the universe's way of understanding and exploring its own existence. The cosmos is not just out there, it's in us. We are the living, breathing manifestation of the universe's curiosity. We are a way for the universe to know itself. Our quest for knowledge is a reflection of the universe's own quest. Keep looking up, keep wondering, and keep exploring. The universe is vast and there is so much more to discover. The universe is full of amazing stories just waiting to be discovered. Each star, each galaxy holds a tale of cosmic wonder.